Our last distance technique is using spectral type to determine the distance. Again, the key is finding the absolute magnitude, and we can do that using the spectral type as well because of the HR diagram and the relationship that we know occurs for a main sequence star. So when you have a main sequence star, we know that it's going to fall somewhere along that line. So from the spectrum, we know its temperature or its spectral class. So we find where it is horizontally, and then we just read off based on where it is on the HR diagram the corresponding absolute magnitude or luminosity. So for every spectral type, we get the absolute magnitude, as long as it's main sequence. Now this is limited to main sequence stars. But that's 90% of the stars. So that's helpful. And then, of course, our last step is comparing apparent and absolute magnitudes to get the distance. So again, we've got apparent, we've got absolute. Apparent we get by observing how bright it appears. And now absolute we're getting from the spectral type. And then, of course, our last step is which is brighter. So if the apparent is brighter than the absolute, then we know it's closer than 10 parsecs. If they're equally bright, it's 10 parsecs away. And if the apparent is fainter than the absolute, then we know it's greater than 10 parsecs away. So that last step, whether we're dealing with Cepheid variable stars, RR Lyra stars, or main sequence stars, always comes down to comparing the apparent magnitude and the absolute magnitude. And that is ultimately how we always find the distance when we can't measure parallax.